there. And I appreciate you all coming here. Doug's presentation, described as occupational safety, is actually about safety first, innovative digital transformation solutions. And so he'll be talking for the next 45 minutes with some room for Q&A. So a little bit about Doug, who's with Emerson. Doug is a principal consultant for Emerson Automation Solutions with more than 35 years of international experience. I'm going to do this. My reading glasses are not here. Designing, justifying, installing, and commissioning advanced real-time automation, optimization, and digitalization applications of the petrochem and oil refining plants, and assessing their safety, economic, and environmental impact. He's published more than 50 papers on this application of this technology, and previously has held senior management positions in several organizations. He's got a BS Chemical Engineering from the University of Florida, an MS from CIT, California Institute of Technology, and an MA and PhD from Princeton. So welcome, Doug White from Emerson. Thank you.
Welcome, and we have a small group, so let's keep it informal. If you have a question, let's ask it at the time you see it. First, a commercial. Okay, I'm with Emerson, and we're very proud of our work with regard to safety and environmental activities. This is Emerson. It's founded in 1990 and still under the same name. And we have operations around the world with almost every country. We have some products available and delivered. Environmental sustainability, our Chief Sustainability Officer is Mike Train. And you'll get a copy of this presentation when it's available. If you click on that particular site there, it will go to our particular discussions about sustainability. So I'm going to talk about how new digital technologies can improve safety. And again, thanks for the invitation. I want to start with a actual video. What happens when safety goes bad? So that's an example of what happens when safety goes bad and things are not done properly. So how can new digital technologies help? Well, this is 3 examples from some of our clients. First of all, having device diagnostic software, which is standard now with our transmitters, identified a problem in a boiler control transmitter that would have resulted in a large impact on production as well as a possible safety incident. So again, using data analytics on key pumps, another major producer detected an anomalous relationship between the pressure reading and the flow on the pumps and the motor amps and temperature. And that would have been something that would have been very difficult for someone to identify manually. So it avoided a pump failure that would have created a safety incident and production losses. And then a European refiner was operating 4 similar parallel amine units, and they retrofitted real-time corrosion monitoring in key locations. It was determined, strangely, these were the same material feeding what they thought was the same gas. One of the 4 was experiencing dramatically higher corrosion rates, which had they gone undetected, might have resulted in a vessel failure prior to the next scheduled shutdown. So again, these technologies can improve safety. So what I want to talk about really is what happens with safety incidents, what's the problems, what does the data tell us the problem areas are, how can recent technology advances improve the safety, and then what comes next and questions. So if you have a safety incident, I think of it in these terms, that basically you have 4 different types of impact, possible impacts: personnel, environmental, financial, and community. And so you have to consider all of these in turn. If you think about what the safety performance metrics are, how do we decide whether or not these things are important? Here's the list of the metrics in each of these areas. Occupational safety, OSHA recordables, environmental, tier 1 and tier 2, loss of primary containment, financial losses, and community problems. So clearly a safety incident can have major impact overall. Now the API has standardized their reporting on safety. Recommended practice 754 allows you to look at data that has been collected. Now they have standardized what they're reporting, and the AFPM and the API jointly created the Advanced Process Safety Program. And this is now considers about 90% of the refined product production in the US and about 75% of the olefin and major petrochemical production contribute data to this. And this is publicly available, so you can go to their site and actually see the data on where incidents have occurred. So what are some of the recent developments in safety? Well, there are 3 areas that you have to be concerned about in safety. First of all, OSHA, and that's basically for things that happen inside the plant. EPA basically governs if releases go outside of the plant site. And then also, we have to be concerned today about cybersecurity activities as well impacting safety. And that's the government CISA policy. So in 2017, the National Emphasis Program was enacted, and it applies to refineries and chemical plants. It authorizes inspections, and any violation of a PSM standard is a condition that is considered to be able to possibly have physical harm. So what happened was the safety committee in the AFPM and API went back and looked at a audit of 60 plants around the US in terms of how they were compliant with the CFR, the PSM standard. And so in these 14 different areas, what they found, where this is the number of violations that are number of inconsistencies they found. Notice number 8, mechanical integrity, was the highest percentage. Process hazard analysis and process safety information were next higher. Operating procedures was the 3rd higher. So this is where they found deficiencies in plants based on actual audits. What are the new technologies addressing this? Well, safety information, mobile worker support, plant digital twins, procedural automation for operating procedures, location awareness, asset monitoring, and automation, configuration, and documentations are new digital technologies that can help address the areas that have been found to be most at risk. And recognized and generally accepted good engineering practice, RAGREP, I'm sure that most of you are familiar with this. This is OSHA's requirement for whether or not you're doing a correct job. You can be fined for violation of RAGREP, but there is no rigorous definition of this in the PSM standards. Basically, they refer to these sources and any other industry sources and vendor information as what is recommended practice and what you can be held accountable to. The ISA has published a functional safety, which is very widely used. ISA 6150511, and it's an IEC standard as well, and been adopted really around the world as a basis for definition of what a safety program should be. It's three different areas, and OSHA has indicated that they consider this to be recognized and generally accepted good engineering practice for safety information, safety instrumentation systems. So if you choose to adopt that for your plant, you are following RAGREP for this area. Very important. Okay, the plant that I showed the video of was a hydrofluoric acid alkylation unit. There have been at least 6 significant safety incidents on U.S. Hydrofluoric acid alkylation units. And so this Chemical Safety Board has requested the EPA to update their study on these plants to come out with new standards for safety operation. One of the other things that is a contributor to improving safety has been the adoption of integrity operating windows. Integrity operating windows are now a standard under API recommended practice 584. And this drawing here kind of shows what it means. So for all of the important process variables that you measure around a piece of equipment, this is what you're expected to define. What is the normal operating limits, upper safe, and then alarm limits and other significant areas for violation. Also, EPA has established what they regard as a model risk management plan for refineries. This is published at API publication 760, and it basically standardizes what they expect companies to have put in place with regard to safety programs. Again, the 40 CFR 63 has defined the emission standards for hazardous air pollutions in refineries, and this is the list of all of the different areas that are covered with regard to these areas. Cybersecurity standards. There are many standards and guidelines on cybersecurity. The Cybersecurity and Infrastructure Security Act of 2018 established the U.S. Department of Homeland Security as a central point for cybersecurity, and basically they have adopted standards and are trying to ensure that companies have followed the correct practice. I mean, I think we're all aware of the pipeline issue that happened within the last couple of years that was a significant cybersecurity impact on the petroleum industry. ISA and IEC have put together a series of standards on cybersecurity, really defining the different levels: product level security, system level security, the baseline, and then the general support information. So this is, again, the standard for cybersecurity applications in plants. So what does the data say? With all of this work, how have we done? Well, here are some of the major events and safety events that have happened in the last few years. And 2019 was a very bad year. All of these different events happened in refineries and chemical plants, really in the Houston, Galveston area. So this is not something that has gone away. There still are a large number of these incidents occurring. Now, what does this mean? Well, Marsh & McLennan publishes data on large property damage losses. Basically, this is an incident that costs more than $50 million in terms of insurance claims. And if you look as it goes forward, it increases. And in the last year for which there was data, there was almost $1 billion in insurance claims for major incidents in refinery. Well, what does that mean? Well, it means your companies are now paying higher rates for insurance, and in some cases, higher deductibles before the major policies come into effect. And so certainly safety issues can have an impact on the bottom line in terms of the cost of insurance. What does the data say? Well, first of all, they say that mechanical integrity failure is about roughly 43%, and non-mechanical failure is about 57%. So you might say 50-50 in terms of the reasons for the large losses. And if we look at the primary reason, notice that up here, you can see that internal and external corrosion are the largest component of the reason for having these large losses. Okay. Under the operating modes, it's not just startup and shutdown. You can see that under normal operation, it still is something for concern. If we look at non-mechanical integrity failures, what do we mean by that? So here are some of the areas that they find for common causes for major instances: coke drum switching, delayed cokers, tank switching, bypassing, manual cleaning of line blockages, inadequate equipment isolation. All of these are major areas for problems. Okay, you're familiar with Tier 1 and Tier 2 loss of primary containment. The AFPM also publishes data on that, and you can see that the rate of incidents has been going down for both refineries and petrochemicals, but it still is much too high. All right. So again, what does the data say that the primary problem areas are? Well, here's the point of release. You can see the piping systems and atmospheric tanks are number 1 and number 2 on the list. About 48% are in piping and other areas. In the area in the refinery where there are problems, the number 1 area, of course, is tank farm storage and facility offsites. That's the primary area. Secondary area is the crude unit, and then you can see other process units as we go around the circle there. Cyber incidents. There really is very little public data available on the number of cyber incidents that are happening in plants. It's quite difficult, and companies don't seem to want to release this information for some reason. But here is data which can show, again, an increasing number of attempts for cybersecurity incidents. These are all of the, or not all, these are a number of different cybersecurity attacks that have been documented on control systems in industrial facilities. And you can see here that they are, basically targeting different areas. So power stations and basically the enrichment facilities, all of these are areas. 2000, there was a cyber attack on a sewage plant that caused a release of more than 250,000 gallons of untreated sewage. Okay. So how can technology advances improve this safety? Well, if we look what's happening in the technology area, and if you go out to the exhibit floor, you will see many examples of new plant digitalization applications. Basically, it requires combining together improved measurements, connectivity like wireless, storage, sophisticated analytic algorithms, and then some way of displaying. So what's the concept behind this? Well, I always say the value of digitalization is early prediction and mitigation of future potential safety issues. So I think in the past, we had data on what happened right now and what happened yesterday. What we were missing was data that looked forward to help us predict how things were going to operate. And that's what this technology really is trying to do. Bring us to the point where we can go forward and look forward at where there are problems. So this is a Swiss cheese model, which perhaps you are familiar with, which looks at different areas and uses those to analyze what went wrong when we have a high severity incident. These are the major components. And where digitalization can provide safety risk mitigation is in the areas listed here. Staff training, equipment maintenance, alarm systems, safety shutdown systems, and relief systems. So digitalization application can provide additional risk mitigation. Okay, here's more data. Again, if we look at the tier 1 and tier 2 loss of primary containment and look at the data that I indicated was in the AFPM and the API database, 49% was due to piping. Okay, again, that's consistent with the large losses from Marsh and McLennan. 11% due to tanks, okay? Tank overfill problems or other issues, 8% pumps, exchangers. And some of the areas where new digital technology can help with that, in the piping area, real-time corrosion monitoring, tanks with complete safety systems, including redundant tank overfill protection, heat exchangers, pumps, and fire heaters are shown here. So this is the solutions that are available now to address these problems. They are, available and in use at refineries and chemical plants around the world, and so it really can help to make the plants better. Tanks, again, are continuing to be a problem. These are just a list of some of the overfill incidents that have led to major losses. I mean, Fixborough is the one that is most well known. Happened in 1974, but it actually registered on the Richter scale for equations for basically earthquakes when it happened. But all of these are different areas of where tanks overfill protection. There is a API 2350 now as a standard to indicate what the recommended practice is for tank overfill protection, which involves redundant measurements and use. And again, that is available as well. Other safety equipment available is emergency lighting, a whole bunch of different areas listed here. And basically, kind of the summary of this is there is a continuing evolution in government regulations, RAGAREP being the most important. Current status in refining and petrochemical occupational safety, there has been a significant decrease in the incident rate, but it's leveling off. And process safety, there's still a significant number of incidents of high significance. So digital technologies have the potential to provide early detection of potential safety incidents and to mitigate the consequences. Cybersecurity incidents are a growing threat that have to be implemented. And fundamentally, Emerson has a comprehensive set of equipment and services to help improve the safety at your plant. So if you get a chance, come see us. We have two booths, 4307 and 4308, and we can talk about these different areas. So that's kind of it. Let's kind of went through that quickly. But questions, discussions, what are you seeing as the problems in your plant?
And Doug, I'm going to ask if you wouldn't mind going back, was it 2 slides, just to your, we can use the
Right.
Take Laura.
Okay. So anybody talk about particular safety issues in their plant that they want to, that they're aware of? Or solutions?
I have a question.
Sure.
I'm just wondering when digital solution comes in compared to, for lack of a better word, the analog
Right.
version that's been entrenched and in place.
Right.
What's sort of the types of transition issues or opportunities that you're finding? Because I would imagine that people are used to their way of doing things.
Sure.
Now there's something new.
Sure. Well, we always say that there are three components: technology, operating procedures, and people. So when these new technologies come in, first of all, of course, you have to install the technology and the infrastructure to take advantage of it. So that's a primary area. Second point is you have to embed the use of those technologies in the actual operating procedures, okay, so that it's part of what's expected of the plant people to be able to do that. And then third, you have to provide training for people for new technologies. It's just like anything else. If someone gives you a new technology for use in your home, they don't provide any training or any ability for you to know how to use it, it's going to sit there and not be used. All right. So the three areas of technology, procedures, and people are what we say are always required to implement any new technologies. And that includes the new technologies we get here. But these have been successfully installed at hundreds of plants around the world. And so those plants have been able to implement them successfully. So there's no reason to expect that your plant would not be able to as well.
Remotely, will you alert happen?
Absolutely. So that's part of the interface, and we're all used to our phones now, our smartphones, and getting information on our smartphones. So these systems have the ability now to actually send an alert to your phone and tell you or tell the right person in the plant that they should take action, that this is something they should go look at and correct. So.
And I'm assuming it's on both iOS and Apple.
Oh, yes, absolutely.
I gotta ask.
Yeah,
Safety isn't gonna.
Safety is not
when it comes to the operating system.
Safety doesn't care about your operating system. Okay.
People care about the operating system.
I'm assuming they can tie into shutdowns.
Yeah.
Where they can trigger your ESP.
Yeah. Now, as I said, the SIS, safety instrumented systems, you have to make sure those conform to standards like the ISA standard, which is designed specifically to define what you need to do for safety instrumented systems in terms of redundancy and checking and things like that. But absolutely, it can send you an alert saying that it's the safety system has triggered and is shutting the plant down. But that's not what you want.
Right.
What you want is something that sends you an alert that says, this is a problem that's going to occur soon, and you really need to take action now to avoid the safety instrument system shutdown.
I was in opt-out. We had a conversation a little bit beforehand about shutdowns.
Right.
You were explaining to me, because I had said, oh, is it just wearable technology? Well, it's more than that. So I appreciate this through your presentation. If you want to share a little bit about how that physically looks like when there is a shutdown.
Yeah.
What happens with the folks?
One of the areas of problems is if you have a turnaround or a shutdown in a major refinery or chemical plant, you can have literally thousands of contractors coming in to do work on different areas, literally thousands. I mean, in some cases, 2,000 on a major shutdown or at least several hundred, okay? Now, those people are going to come in, they're not familiar with your plant, they're not familiar with your procedures, and they might inadvertently wander outside the safety area that you've defined for the turnaround. So with the new wearable technology, it can alert someone that they are going into an area they shouldn't go into. It can also tell the operators that they now have someone entering an area that they're not supposed to go into. And that has proven to be a very effective tool, because how do you manage several hundred people doing work on the units at the same time? I mean, how do you keep track of what everyone is doing and making sure nobody does something stupid, right? So this has been very valuable for that. And then also checking to see, are people in where they're expected to be? Are they working on the type of job that they're expected to be working on? And if a bunch of them seem to be sitting around, what's wrong? What are they missing? What are they missing in terms of equipment or tools to be able to get to the point where they're working? So that technology has become very popular now. And even on the safety side, on the occupational safety side, if someone is down and immobile for a period of time, that will alert the plant. For your showers, your safety showers in the plant, those can be set to be triggered. So if a safety shower is in use, it'll trigger alert back to the central control that there's a potential problem. Anyway, just basically this people management part, you can automate a lot of that, which is really important in these very difficult and turnarounds, which are always under time pressure. Always, when the unit's shut down, you're not earning any money on it. So the pressure is always to hurry up and get it done, and to not go over the scheduled time for it. And so this can help a lot with that.